Suppose you're in charge of designing cars for a car manufacturer. You could create independent design blueprints for the manufacturer's 5 car models, but to save time, it's better to first make a master blueprint that describes the common features to all the models, right? Then make additional blueprints, one for each model. The additional blueprint describes features that are specific to the individual models. Creating a more specific blueprint that's based on an existing master blueprint is analogous to the concept of inheritance, in which a new class is derived from an existing class. You can see here we have an automobile is derived from a vehicle, a boat is derived from a vehicle, a truck is a type of automobile, a car is a type of an automobile, a freighter is a type of boat, right? It's called inheritance because the new class inherits and borrows all of the features, that's data and methods, of the existing class. So in this case, an automobile can do anything that a vehicle can do and more. And same thing with the boat, right? A boat can do anything that a vehicle can do because it is a vehicle, but it can probably do more. So both automobile and boat are vehicles, and all vehicles have certain properties that they have in common and things that differ. Inheritance is a very important feature of Java and all object-oriented programming languages for that matter, because it allows programmers to reuse existing software. More specifically, the existing class is used by all of the classes that are derived from it. So here's a UML class diagram for an inheritance hierarchy that keeps track of people in a department store. You can see that we start off with the person class. The person can be extended to create the customer and the employee class. The person class contains generic information such as name. We can further extend the employee class into 2 more classes, full-time and part-time. And as we get more specific or specialized, we add additional information about the object and behaviors that would not apply to the parent class. For example, it wouldn't make sense for all persons to have an hourly wage field, as not all people are hourly employees, let alone have a job, right? But our store employees can be broken down into more specific types. So as we go down the hierarchy, things get more specific and less generalized, right? So we say the person is generalized, right? But the full-time employee is specific or specialized. With inheritance hierarchy, pairs of classes are linked together, similar to our aggregation and composition. For each pair of linked classes, the more generic class is called the superclass, and the more specific class is called the subclass. So in this example, person is a superclass. Employee and customer, on the other hand, are subclasses of the person class. Additionally, employee is a superclass of full-time and part-time classes, while full-time and part-time classes are the subclasses of employee. So this guy, person is a superclass, employee is a superclass, but then customer and employee are also subclasses, and full-time and part-time are subclasses, right? So you can be both at one thing depending on where you're at in the hierarchy. Just like, people, right? You can be a parent and a child at the same time. We say that subclasses are derived from superclasses, and that makes sense when you realize that subclasses inherit all of the subclasses' data and methods. Unfortunately, the terms superclass and subclass can be misleading. The super in superclass could imply that superclasses have more capability, and the sub in subclass could imply that subclasses have less capability. But it's actually the other way around. Subclasses have more capability than the superclass. Subclasses can do everything that their superclass can do, plus more. And we'll stick with the term superclass and subclass since those are the formal terms used by Oracle, But there's alternative terminologies, right? Programmers often use the term parent class or base class when referring to a superclass. And conversely, they often use the term child class or derived class when referring to a subclass. Okay, so if you hear super, parent, base class, you always need to think higher up in the ancestry, right? And if you hear derived, child, or subclass, then you need to think lower down in the hierarchy. Usually UML class diagrams show superclasses above subclasses, and that's a common practice, but it's not a requirement. The following is a requirement. UML class diagrams use an arrow for inheritance relationships with a hollow arrowhead pointing to the superclass. To be clear, the direction of arrows in UML class diagram is the opposite direction in which the inheritance flows. For example, you can see here that employee is a subclass of person, so person is the parent class, so that's where the hollow arrow will point to, right? It points in the direction of the parent class, or the opposite direction of the inheritance, right? Employee inherits everything from person, but we draw the arrow pointing to the parent object. So it can be a little confusing. So what are some of the benefits for using inheritance? Well, it's a great question. I'm glad you asked. Well, for starters, it allows us to reuse code. The parent or superclass's code can be reused for multiple subclasses, and that eliminates code redundancy and makes debugging and upgrading easier. It also means we don't have to reinvent the wheel for common tasks that might have small variances in our implementation. We can just extend the base class and make our small changes. Additionally, this leads to smaller modules. And this can make debugging easier as we don't have to weed through thousands or tens of thousands of lines of code. So here you can see an example of this at work. We have our person class where the person has a name, and we have a constructor to give said person their name, and we can also use a method to get the name from the person. Then we have employee. Notice that the public class employee extends person. This is how you do inheritance in Java. You use the keyword extends, and then you have the class that you are extending. Now it's important to know that with Java, you only have single inheritance. You cannot extend from multiple classes. In some other programming languages, you can. I believe C# is one that you can. But in Java, you can only extend from one parent class. So you see here that we are adding in an ID field for our employee. But employee has access to all the attributes of a person because it is a person. It is extending it. So here we have our constructor for employee, and here we have our another constructor that's going to build our employee class, right? Now, I just compiled this to show you or to illustrate a point, and that is you can't call this constructor and a super constructor in the same constructor. And you're like, well, what is super? And we're going to get into this later on, but just for now, a super constructor just calls the parent class constructor. So we're going to pass in name. But this right here, if you recall from our, I believe it was chapter 6 or chapter 7, this has to be on the first line of a constructor. So you can call another constructor from within a constructor in a class, but it has to be on the first line. The same is true for the super constructor. You can call the parent constructor, but it has to be on the first line of the current class's constructor. So you can't have both a super and a this in the same line. So we can comment out the this and we can compile our code and it works fine. Or we can comment out the super and compile our code and it'll compile just fine. But if we try to compile it with both, we're going to get a runtime error, or excuse me, a compile time error. So that is an important concept to understand and to get. And here you can see we also are adding in a method called display, which is just going to print out the name and the ID. Also notice that we can call get name. Get name was a person method. Well, employee is a person, so we have access to the get name method, and so we can print out our name and our ID. Now we can go and take a look at full-time employee, which extends employee. So just like our employee was extending person, our full-time employee is extending employee. And in this case, we're adding in a salary attribute. And so we have access to all of employees' properties and all of persons' properties and methods and so on and so forth. So here you can see we are calling its parent's method, constructor, and then we're setting our initial value, right? And then here we are adding in a display function for the full-time employee. And if you notice that employee has a method called display and full-time has a method called display, and this is called method overriding. And we're going to talk about that later on in the chapter. So continuing with our previous example, since name is a private instance variable in the person class, or the person superclass, the employees' classes, methods, and constructors cannot access the name directly, which is the same interpretation of private that we've always had. So how can an employee method and constructors access name? Well, by using the person's class's public methods and constructors, of course. Even though a superclass's private instance variables are not directly accessible from a subclass, private instance variables are still considered to be inherited by the subclass. So for this example, each employee object does indeed contain a name instance variable. If this sounds confusing, it is. So we're going to look at it a little deeper on the next slide. When you are in a derived class, you can call the superclass's constructor using this syntax, right? We saw this in the demo. Super and then the arguments, right? So in our previous case, you would find this in the employee class, right? We're going to do something. A constructor call is allowed only if it's the very first line in the constructor's body. And this rule is applicable for constructor calls to the constructors in the same class using this, and also for constructor calls to the constructors in the superclass using super, which we showed you in the demo. So what happens if you have a superclass call and this in a constructor as the first two lines in a construct like this? Well, we already showed you. You're going to get a compile error, right? As you may recall, in an instance method, if you call a method that's in the same class as the class you're currently in, then the reference variable .prefix is unnecessary. Likewise, in an instance method, if you call a method that's in the superclass of the class you're currently in, the reference variable .prefix is unnecessarily as well. Thus, in the employee class's display method, we can call the person class's getName method like this, as you saw in the demo. Again, notice we don't have to call getName with the dot prefix. Okay, so we don't have to use the dot operator with a reference variable because getName belongs to employee because employee is a person. Now, the designers of Java were fond of calling superclasses constructors since it promotes software reuse. In fact, when you write a subclass constructor and don't include a call to another constructor with this or with super, the Java compiler will automatically sneak in and insert a superclass zero parameter constructor call by default. Thus, although we showed nothing in employee's zero parameter constructor, the Java compiler automatically inserts super in it for us. So these two constructors are functionally equivalent, right? Because this super is going to be automatically put into this constructor, even though we don't do it explicitly.